let's see how we can assist ourselves to come out with the solutions to these questions before we move on to what we have today. Thank you. So let's start with the first one. We know that the y given us in the question, which is 2x squared minus 3, is a function y, and the function y is the same as what? The f of x. Since we want to use the first principle formula, then that means that we have to define the fx plus h2. Right after here, you can choose to expand and simplify before you go and do your substitution into the formula. So let's try that and see. This one will come out. So here, s squared plus 2sh plus h squared. You can choose to write it 2 times and multiply it. You get the same thing. Alright. So here we can continue with it by getting the fs plus h to be, we are just multiplying the 2 inside, okay? So we get 4 Alright, so this is what we have now. So we can now go and do our substitution. That is, when you see fs plus h, you put the function there. But then you bind, it has to be in what? A bracket. So always put it inside what? A bracket. Then the f of x. You know the f of h2 from the question to be 2h squared minus 3. So the whole of this is over h. But don't forget this. Always repeat the limit till you end it. So here should be the limit as h approaching 0. Alright. The limit as h approaching 0. So here we get 2x squared plus 4x plus 2h squared minus 3. Alright, so here you can see something that the 2x squared here will cancel this 2x squared. The minus 3 will cancel this plus 3. So we are getting the limit as h approaching 0 4sh plus 2h squared. All this over h. Wow! We are getting there gradually. Small, we will get there. So, from what we have there, you can see that the limit as h approaching 0 for sh plus 2h squared all this over h. You can see that you can bring one of the h out so that h will cancel this h. The reason is that if you try to do the substitution without simplifying into the list, you are going to get 0 by 0, and which is indeterminate. So, the limit as h approaching 0 factor h out, you get 4s plus 2h. All these over h. So you can see this will take away this. So finally we get the limit as h approaching 0 of 4s plus 2h. So now this means that wherever you see the h, you can put 0 there, because with this you cannot get something like 0 over 0. No, you can't get something like that. So here you can do your substitution. 4s plus 2, and the h is what? 0. Why is it that I'm not repeating the limit here? Because here I'm taking the limit. That is why where I see h, I put 0 there. So with this place, if you repeat the limit again, it is wrong. It's not mathematically correct. Alright, so with this we get 4s plus 0. And that gives 4s. So this means that the derivative of y is equal to 2x squared minus 3 will be what? 4x. And we have obtained from the what? From the first principle. But the question is, the results, which is the y ds to be equal to 4x, what is that results? If you remember, I told you in school that any derivative function, any results you get after using the first principle, that results in terms of s is the derivative what? Function, or the slope what? Function. But here, you know, the dy dx is the same as n. Here, if I specify that you are to find the equation of the target at where, let's say, s be 2 or 3 or 4, that means that I'm specific. So when we set s to be, let's say, 1 or 2 or 3, we get a value. So that will be the slope value. But what we have there in terms of s is the slope what? Function. Thank you. So let's journey through to the second question. Alright. Oh, sorry, I have cleaned the formula, but I know that you have it okay. Because yeah, you have to memorize it to have it okay. Because let's say there's somebody who give you the formula to use it. So in the second question, we have y to be equal to 1 over square root of x. So in using the first principle formula, we define the f of x to be equal to 1 over square root of x. I have already told you in the first question that it means wherever you it means that the y given you is the function, which is the same as well the f of x. So we continue to define fs plus h. This means that wherever you see s, put what there, s plus h. So 1 over square root of s plus h. Just simple. You have s here because s is here. You have s plus h here because s plus h is here. You see that? Just simple. Alright. So from here then we continue by using or quoting the what? The formula. Please, s plus, not minus. Alright, so we can now do our substitution. So this is the fs plus h, which is here, and that is the f of x, which is here. All these over h. Here, if your algebra is not strong, you get it correct and you get it wrong. I'm going to do something, but don't be confused. You know, if you have 2 over 3 over, let's say, 4 over 2. Here, this is the same as 2 over 3 times 2 over 4. You remember? Alright, so we are going to use the same idea here. You are going to do the same idea here. You know here is the same as over 1. So we take the reciprocal to multiply the numerator. Don't be confused, please. So, alright, so the limit as h approaching 0. Here we can take the reciprocal. You repeat the numerator, alright. But with the denominator, we can take the reciprocal of it to multiply whatever is in the numerator. So either we get 1 over h, be multiplied by the function. I hope you're not confused. I know you are a good student. Alright. Alright, so now, let's continue. It's still algebra, okay? Don't be. Alright, so looking at what we have in the bracket, we can find LCM. Yeah, that's the only thing you can do. Without it, you can't continue again. So we know the LCM of square root of s plus h, square root of s b. So that means that this will multiply this will multiply this. So that will be square root of s minus. Alright, so let's continue. So the limit as h approaching 0. Now we have s minus s plus h. All these over. Remember, this is going to multiply this. But don't forget yourself that if you have a times square root of a times square root of b, it will be, since the inside are not the same, you are going to get square root of a times what? The b. So the same way, this one will be left with only one root. So the s plus h will go and multiply this with s. You are going to have something like that. Then this h too will come and multiply. And this one, when it multiplies whatever is in the numerator, is still the same thing. So we get our h. So we can simply write this as this h will come out right here. This and this, you get what? S squared. This s times this, you get sh. Please, I beg you, don't multiply this h inside the square root. You know that can be possible. But you are missing it. Alright. So now this is what we have. Wow. What do you see? What do you see now? Now let's see. If you like, let's try and do substitution of the h. Like where you see h, put 0 there and see if it will work. So if you put 0 here, everything in here, this one we are going to get square root of s, which will give you 0. And without considering even the inside. If you put 0 here, everything here too will be 0. So you still get 0 over 0, which is indeterminate. Alright, so that means that we have to still continue with our what? Algebra. And the only thing to do here is to do what? Rationalize the numerator. Alright, good. I know you are good students. Alright, so we continue with our rationalization. So the limits as h approaching 0, root of s plus h, all this over. So we are going to rationalize. I use space to do this. So in rationalization, you know that we are rationalizing the numerator. As I said, it's not, when we were in SHS, always rationalizing the denominator, but it's not always the denominator. You can also rationalize the numerator too. So change the sign to plus. I beg, it's still plus. H. The same to repeat. It's like you multiply whatever here by 1, it won't affect it. So now, this means that everything in the numerator is multiplying itself. And with this, I have told you that if you multiply the whole of this by this, the whole of this by this, you will still achieve something like the same as you considering where the negative sign is. Then you multiply everything there, then you square it. Then you also multiply this by itself. That's the same as you would square it. The whole of this over here to this is multiplying whatever is here, which is h. I love mathematics. Don't you love mathematics? Let's continue with it. Alright, so we have the limits as h approaching 0. This will cancel this. This will cancel this. Hey, but remember, the negative there will affect the inside. So don't remove it. Don't remove the brackets. All this one too is going to multiply. Now repeat the same thing. Let's see what is going to happen to the numerator. Hey! You see, there is something wrong there. The negative will play the inside. Sure! So that will give you negative. Alright, you see, how can I see it? So, you are going to leverage. Let me try and bring it here. So, everything on top is left with what? Negative h over this h multiplying square root of s squared plus h. Alright, multiplying the x squared plus h being multiplied by sorry, I hope you can see from there. Alright, so here be careful. You see that this, we are all multiplying itself, right? So we can say that this h will cancel this h. So that we are going to be left with the limit as h approaching 0 of -1 over s squared plus h square root of s plus square root of s plus h. So we are going to have something like this. Nice. Nice. And here we can take our derivative. Now wherever you see h, put one there, 0. So this is going to be the limit as h approaching 0, -1 all over. This one will be s squared. Here will be raised to square root of s, because this will be raised to square root of s, this is square root of s, that is 2 square root of what? X. So you can see that here this one will cancel this. If you don't understand anything, you can play back the video and you will get it, because you know that here will be like with what? Square root of s squared, and here will be square root of s square root of s, which is 2 square root of what? X. So here we are left with the limit as h approaching 0 of -1 all over. Now the square will take away the roots. So we are going to be left with s multiplying to square root of what? X. So that is going to give you, but don't forget that since we are substitute 0 to where h is, no more bringing the limits again. So we have our dy dx to be equal to that 2. You can change this to half, multiplying by this the same as that. So we get 2x or half. We can add from indices plus 1. So that is going to give us -1 all over 2 square root of, or let me first leave it as this for you so that you won't be confused. 3 over 2. Oh, I don't normally believe myself. Why is my calculator? Alright. So 1 plus 1 over 2. Yeah, it's 3 over 2. Yeah, I don't believe myself. That's mathematics. So, but we can end this as 2 square root of its power 3. Alright, so that becomes the final answer. That is the derivative from the first principle of the function 1 over square root of x. So, if If you don't understand anything, you can play back the video, watch it again and again, and you will get it. Thank you very much.